Ginger, also known as Gingiber officinale, is a plant that commonly used in cooking and traditional medicine. It also contains important bioactive compounds such as gingerol, sugarol, and gingerone, which give ginger its strong taste and aroma. From a chemistry point of view, this compound is a phenolic compound that have a specific chemical structure and reactivity. These chemical properties are responsible for ginger antioxidant, anti-inflammatory, and antimicrobial effect, which make it beneficial for health application. Therefore, understanding the chemical composition of ginger can help explain why it is widely used in food, pharmaceutical, and health-related products.
Have you ever used ginger to relieve stomach discomfort or cold symptoms? Ginger is not just a common kitchen spice, but a plant rich in bioactive components that provide many health benefits. Today, I will be discussing the benefits of ginger. First, ginger is used for anti-inflammatory effects. Ginger contains bioactive compounds such as gingerol and sugarol that reduce inflammation by inhibiting the synthesis of inflammatory mediators. Number two, it is used as antioxidant properties. The phenolic compounds in ginger act as antioxidant by scavenging free radicals, thereby reducing oxidative stress and cellular damage. And the third benefit is it helps in aids digestion. Ginger stimulates digestive enzyme and enhance gastrointestinal motility, helping to relieve indigestion, bloating, and stomach discomfort. Next, number 4, it also helps to relieve nausea and vomiting. Ginger is effective in reducing nausea related to motion sickness, pregnancy, and chemotherapy by influencing gastric emptying and intestinal activity. Number 5, it also helps in antimicrobial activity. Ginger exhibits antibacterial and antifungal properties due to its active compounds, making it useful in medicinal and food preservation application. And the last one, number 6, the benefits is supports cardiovascular health. Studies suggest that ginger may help reduce blood cholesterol level and improve blood circulation, contributing to better cardiovascular health.
For 6-pyridol, its homologous series are phenol and ketone, but for its functional group, it's hydroxyl and carbonyl. For 6-sugarol, its homologous series are alkane, ketone, and phenol, and its functional groups are double bond, carbonyl, and hydroxyl. Next is gingerdione. Gingerdione homologous series are phenol and ketone, and its functional groups are hydroxyl and carbonyl. The fourth one is 6-gingerol. Its homologous series are alcohol, ketone, and phenol, and its functional groups are hydroxyl, carbonyl, and also hydroxyl. The last one is zingerone. Zingerone homologous series has phenol and ketone, and its functional groups are hydroxyl and carbonyl. The first compound is zingerone. Zingerone has a relatively low melting point, around 40 degrees Celsius. This is because it is a smaller molecule and does not have long carbon chain. So, the intermolecular forces between its molecules are relatively weak. However, its boiling point are much higher, around 290 degrees Celsius. This is due to the presence of hydroxyl and carbonyl groups that increase its intermolecular attractions. Next is 6-gingerol. 6-gingerol has a low melting point, around 30 degrees Celsius. This is mainly due to its long flexible alkyl chain, which prevents efficient packing of molecules in the solid state. Despite that, it has a very high boiling point, around 450 degrees Celsius, because of its large molecular size and strong London dispersion forces. Next, we're moving on to 6-sugarol. 6-sugarol also has a low melting point and is often liquid near room temperature. The long alkyl chain and reduced hydrogen bonding weaken the solid structure. However, its boiling point remains very high, around 430 degrees Celsius, because its large molecule size results in strong intermolecular forces that requires a significant amount of energy to overcome. The fourth compound is gingerdione. This compound has also a low melting point around 40 degrees Celsius. Although it contains two carbonyl groups that increase polarity, the presence of a flexible carbon chain prevents efficient molecular packing in the solid state. Its boiling points are also high, approximately 380 degrees Celsius, due to the combined effects of dipole-dipole interactions and London dispersion forces. And the last compound would be 6-pyridol, which also has a low melting point around 31 to 33 degrees Celsius. Similar to gingerol, its long alkyl change reduces efficient packing of molecules in the solid form. It also has high boiling point of around 460 degrees Celsius because of its relatively large molecule size and strong van der Waals attraction.